Hello everyone, my name is Naman Goyal and I am your mathematics faculty. Okay, in previous lecture what we learn about? See, we learn about what? We learn about area of circle, area of sector and perimeter of a sector. Okay, so in today's lecture what we learn about? See, we learn about area of circular path or ring. See, if I give you a circular ring like this and if I'm asking for that area, so this is known as circular path, or we consider a circular ring, right? So in today's lecture, we are going to learn about how we find out the area of these types of figures. Okay, first of all, this thing, and after that, area of segment. You know what is segment? I told you in previous lectures, previous to previous lecture, first lecture of this chapter. See, what is segment? This there is a chord. So this is what a segment. So how we find the area of this segment? And now there are some combined figures, combinations of two figures, two or more than two figures, we can say that. How we find the area of that figures we are going to learn in this chapter. Okay, any problem? No. Okay, so if I see what is the area of circular path and ring, see, if I told you to find the area of this yellow part, so this is what a circular ring. If I'm asking you this design area, this is area of ring. If I'm asking for this area, this is a circular ring. Are you getting my point? Okay, isn't it? Yes. Okay, so first thing is what? Area of circular path or ring. So the area of a circular ring bounded by two concentric circle. Concentric circle means what? When the circles have same radius, then same, not same radius, with the same center, then they are known as what? Concentric circle. Okay, so the larger circle have radius r and capital R, and the smaller circle radius has small r. So let me show you how we do this. Okay, see, if there is a circle, if there is a circle, we have this one which is r2, and if there is a circle with r1. Okay, or we can take capital R and small r. So if there is a circle, if there is a large circle and there is a smaller circle, you can take r2 and r1. So the area of that shaded part, area, why it's not visible? Let me check, give me a minute. Okay, give me a minute. Yes, now it shows. Now see, I have to remove this. Okay, now see, area of that shaded part is what? See, there is a circle outside and inside. This is small r and this is capital R. So area of this circle, we can say that area of shaded part, area of shaded part, we can say that it is equals to what? Area of larger circle minus area of smaller circle. Area of bigger circle minus area of smaller circle, isn't it? So the tell me the area of this bigger circle is what? Pi capital R square. Pi capital R square minus the area of that smaller circle is what? Pi small r square. Now you can see I can take pi common. So if I take pi common, it gives capital R square minus small r square, isn't it? So capital R square minus small r square. So pi into r plus r into r minus r. How we got this r plus r and r minus r? We are going to use a property which is a square minus b square, and it is nothing but a plus b into a minus b. So if you are talking about this question, see, area of bigger circle minus area of smaller circle is the area of what? That ring, or we can say that part, that shaded part we want. Okay, So area of bigger circle is what? Pi capital R square. Area of bigger circle is what? Pi capital R square, and the area of smaller circle is what? Pi small r square. So we can take pi common from these two, right? We can take pi common from these two. So what we get? We get capital R square minus small r square. Now see, this capital R square and small r square makes this identity, which is a plus square minus b square is nothing but a plus b into a minus b, right? So pi into capital R plus small r into capital R minus small r. So we can say that the area of that circular ring is pi into capital R plus small r into capital R minus small r, where capital R is the radii of the outer circle. This is circle, okay, and small r is the radii of what? Inner circle, okay. This small part is the, this is what? Inner circle, and this is what? Outer circle, and the part we solve is this area, okay. Are you getting my point? Okay, now there is a question we are going to do. Okay, now let's see how we do this. Now in this question, the inner diameter and outer diameter are given. Inner is 65630 and outer is 658. Then find the area of this circular path. We can take, the question is asking for this area, okay. So first of all, we are going to find inner radius is what? Diameter upon 2. We know that the diameter d1 upon 2, which we can take as r1, okay. So the inner radius is what? 630 divided by 2. How much you got? If you divide 630 by 2, you will got 315 meter, okay. And r2 is what? Outer radius is what? We can say that this is d2 by c. What we do, I just take this quantity as d1 and this quantity as d2. So we can say that the outer radius is what? D2 by 2, because diameter ka half is radius, right? So it becomes 658 upon 2. So if you calculate 658 divided by 2, then how much you got? 329 meter. Now we know the formula. Area of circular path. Area of circular path is what? Pi comes common, capital R1, or we can say that R1 plus R2, because we take R1 plus R2 into R2 minus R1. Why we take R2 minus R1? Because here we take R2 as greater radius and R1 as smaller radius, right? So it will be R2 minus R1. If you take R1 minus R2, then it becomes a negative. And how it can be possible the area can be negative, right? It is not possible that area becomes negative. Are you getting my point? So what we have to do, we have to take R2 minus R1 only. Okay, no doubt. Okay. Now simple, what we have to do, we have to put the value of R1 and R2. So pi is 22 by 7, we have to take. R1 is what? 315 plus 329. 329 minus 315. So how much you got? 315 plus 329. You got 644. So 22 by 7 into 644 multiplied 14, right? 14. So 7 twos are 14. Oh, very big. Okay, now into 2 into 22 into 2 into 22, right? So what you get? 22 into 6 4 4 into 2. How much you got? You will got 2833, not 6. You got 28336 centimeter, not centimeter, meter square, because it is the area. So we have to use the unit of area only, and the unit for area is what? Square unit. So in this question meter is given, that is why we have to use meter square only. Okay, so if you see the solution, 28336 is the answer, and it also use the same method. I'm going to teach this method also. So if you see what I use black highlighter and it disappear our main thing. Okay, now see. Yes, inner radius is what? This quantity 315. Outer radius is 329. Now formula is what? Pi r plus r, capital R plus R into capital R minus R. So which will be 227 into 329 plus 315 into 329 minus 315 meter square. This is m2 is not 2 is in the square. Okay, so there is a error, slide error, we can see that. So this quantity is nothing but m2. Okay, this is like this. Okay, now see. Yes, this is like this. Okay, now this is 227644 into 14. Okay, now you can easily do this. Okay, you will get 2836336. Okay, now next thing which is very important. This quantity is very important. Okay, now see. Yes, now see, next thing is what? Area of segment. As I told you in first lecture, what is segment? See, if there is a circle I drawn, there is a chord, so that part is known as what? Segment. And now question is asking for what? The area of that segment. Okay, now see, there is a formula, direct formula you can use for the area of segment, but if I'm talking about NCRT, the formula is not given in NCRT. The formula is not given in that NCRT. So we are not, if we are not using the formula, direct formula, if you are talking about your board exams, then it will be more helpful. Okay, so in your board exam, for your board exam, you are not going to use this formula. See, there are two formulas. As I told you, radians is the measurement of degree, and degree, not degree, radian is the measurement of angle, and degree is also the measurement of angle. And we know that we learn about this, ki pi is 180 degree. Pi radian is what? 180 degree, isn't it? We learn about that part, right? Okay, so area of segment in radian, if you are talking about area of segment in radian, okay, so the formula is what? 1 upon 2 into r square into theta minus sine theta. And if you are talking about the area of that segment in degree, then the formula is what? A is equals to 1 upon 2 r square into pi upon 180 into theta minus sine theta. Are you getting my point? Okay. But the point is what? The question arises in your mind, ki sir, if we are not going to use this formula, then how we do this question? This is the basic question you got in your mind, कि sir अगर आप बोल रहे हो कि we the formula is not given in the NCRT, so if the question comes in our board exams, so which formula we are going to use, है ना? So how we do this? We just follow the basic method to find that area. Now let me show you the method is what, and with the help of question we got more clarification about this method. Okay, so for now I just give you some idea. ठीक है, तो देखो ये है हमारे पास एक triangle and this is sector. So we can say that if this point is O, this point is A, and this point is B, so we can say that area of required segment is nothing but एरिया ऑफ दैट सेक्टर. अगर मैं इस पूरे सेक्टर के एरिया में से I subtract the area of this triangle, then what we got? We got the area of segment, isn't it? क्या बोला मैंने, इफ वी सब्ट्रैक्ट द एरिया ऑफ दिस ट्राइंगल फ्रॉम दिस एरिया ऑफ द सेक्टर, वी नो द फॉर्मूला फॉर एरिया ऑफ सेक्टर, है ना। तो हमें सेगमेंट का निकालने के लिए हमें क्या करना चाहिए था, करना चाहिए कि वी हैव टू सब्ट्रैक्ट द एरिया ऑफ दैट ट्राइंगल AOB फ्रॉम द एरिया ऑफ दैट सेक्टर AOB, so we got our required answer, right? So but the point is कि sir, how we find that area, which area, that triangle area, how we find it? So just focusing on that part. Okay, now listen, what I do, area of required segment is what, area of sector AOB minus area of triangle AOB, ठीक है। अब सेक्टर का एरिया तो हमें पता है, अवर मेन टास्क इज व्हाट, वी वांट्स टू फाइंड द एरिया ऑफ ट्राइंगल AOB, है ना। So listen carefully. So therefore we are going to find what, we are solving this equation for what, area of that triangle AOB, area of triangle AOB. Now listen how we find this. For finding the area of any triangle, what we need two things. One is height and second is perpendicular, height and base. So एक काम करते हैं, what we do, I just draw a perpendicular from this. And there is a property of a circle, if we draw a perpendicular from the center, then these two triangles are congruent. So it means this side is equals to this side, and this angle is complete theta, then this is theta by 2 and this is theta by 2. Now I can take this point as M. So in a triangle, in not A, MOB, this angle is theta by 2. So what I want to use, I am going to use cos theta. What I'm going to use, not cos theta, I am going to use, yes, I can use cos theta because this radius we have, cos theta, theta by 2. So basically if I using cos theta by 2, it will be give what, base upon hypotenuse, base is OM and hypotenuse is what, OB, which is R. So with the help of this one we can find the value of height. Similarly, if we use sine theta by 2, then we can find the value of this MB. And once we got MB, then what we got? We got AB also. And if we got AB, if we got OM, AB is base and OM is height. Then the area of that triangle is what? 1 upon 2 into OM into AB. So we can use that formula, right? So we can do this, okay? ठीक है, कर लेंगे इसको। देखो अगर आपको नहीं समझ में आया तो नो प्रॉब्लम, हमें देखो ये फॉर्मूला प्रूव नहीं कर रहे अपन, व्हाई वी आर नॉट गोइंग टू प्रूव दिस फॉर्मूला, बिकॉज दैट फॉर्मूला इज नॉट गिवन द एनसीईआरटी। बट जो मेथड हम यूज करेंगे, द मेथड वी आर गोइंग टू यूज फॉर सॉल्विंग दीज टाइप्स ऑफ क्वेश्चन, दैट मेथड गिव सम मोर क्लैरिफिकेशन व्हेन वी टेक अ प्रॉपर क्वेश्चन, है ना। जब हम एक क्वेश्चन से देखेंगे तो हमें अच्छा समझ में आएगा, बल्कि अगर हम cos थीटा की टर्म में, r की टर्म में देखेंगे तो हम थोड़ा कंफ्यूज हो जाएंगे। So that's why I'm not going to show your proof right now. We are going to learn the concept with the help of a question. Okay, any problem? No problem. So we have the question here. Okay, so there is no problem to worry. Okay, now what is the area of segment corresponding to the arc subtending an angle of 60° at the central, and radius is also given. ठीक है, same question है, the radius is given and the central angle is given, and it's asking for what, it's asking for what, it's asking for area of segment. So सबसे पहले देखो हम क्या बोलेंगे कि area of segment is what, area of sector AOB minus area of triangle AOB, ठीक है। So first we are going to find that area of triangle AOB. So area of triangle AOB है ना, पहले अपन area of triangle AOB के निकल रहे हैं, तो अपन क्या बोलते हैं यहाँ पे, for area of triangle AOB. Now let's see what we can do. What I do, I just draw a perpendicular and take this point as C, and this is 90°. ठीक है, so in a triangle OCB, this triangle, OCB. In this triangle, this angle is 30 degree, this angle is 90 degree, this is 6. So what I'm going to take, I'm going to take cos 30 is base. See, this is base, right? This quantity is base, right? Base is OC and height is height not hypotenuse. है ना? Base upon hypotenuse is the formula for cos theta. So cos 30 is what? Base is OC and hypotenuse is OB. OB is 6 centimeter. ठीक है? This is what OB. Now cos 30 is root 3 by 2 into OC is equals to not into is equals to OC upon 6. So the value of OC we got 3 root 3 centimeter. ठीक है? Now we are going to use sin 30 degree. Sin 30 is what? Perpendicular मतलब BC upon 6. So BC is what? 3 centimeter we got. What we got? 3 centimeter. Okay. Now area of that triangle AOB. Area of triangle AOB is 1 upon 2 into base is what? AB and height is what? OC. So AB is the base. अच्छा BC अगर 3 है तो we can say that AB is 6 centimeter. So it will be 1 upon 2 into AB is what? 6 into OC is what? 3 root 3. So how much we got? It will be cancelled out by 3 times. It will give 9 root 3 centimeter square. ठीक है, तो we got the formula, we got the value of that area of triangle. Now I think you got the concept how we find the area of that triangle. ठीक है. Now for area of segment, what we have to do, we have to subtract the area of triangle from the area of sector. ठीक है. So we don't have so much space here, so we are going to write down our continue our question here. Okay. Now ठीक है. Now see, now area of segment is what? Area of sector minus area of triangle AOB. So what we need, see, we already find that area of triangle AOB. So what we need area of that sector. So area of that sector is what? Theta upon 360 into pi r square. Theta is what? 60 degree upon 360 into radius. How much the radius is? 6, right? 6 is the radius. So pi into 6 into 6. So 66 times 6 cancel. How much we got? 6 pi centimeter square. And area of triangle, how much we got in previous slide? We got 9 root 3 centimeter square. So we can say that area of segment is equals to area of that sector 6 pi minus area of this triangle, and the area of triangle we got is 9 root 3 centimeter square. So 9 root 3. So now you can take 3 common. So it gives 2 pi minus 3 root 3 centimeter square. Got it? If you see, we got the same answer. Is there any doubt in this part? So as I told you, as I promised you, if I'm going to show the proof of this formula, then it becomes more typical. But if I'm going to show this concept with the help of question, then it will seems very easy, right? So what is the concept behind area of segment? What we have to do, we have to find the area of sector, and then we have to subtract the triangle area which is made by that chord and 2 radius. Are you getting my point? Isn't it? है ना, यही किया अपन ने. ठीक है. So for the area of that triangle, what we need 2 things. One is perpendicular height and second is base. ठीक है. So you can do these types of question like that. Okay. Okay, so we do question now. Now next concept is what? Area of combinations of plane figure. Okay. So what is the combination of a plane figure? We can combine two or more than two figures combinedly, and we are going to find the area of that figure. For example, a collection of points that can are on the same plane is known as plane figure. ठीक है, plane figure अपने को पता ही क्या होता है. It's involve the area of the figure which has a non-standard form is involving basic geometrical figures such as circles, square, triangles, rectangles, etc. and so on. Now see, if I give you a question to find the area of this figure. Now if you see, there is a rectangle. Why it's become disappear again and again? There is a rectangle A, B, C and D. So for this complete area, what we have to do, we have to add the area of this rectangle plus C. Now there is a semicircle and there is another semicircle. So what we have to do, we have to add these the area of these two semicircle with that area of that triangle. So area of figure is nothing but area of rectangle plus 2 into area of semicircles, isn't it? If you see in the figure, we got the same. Are you getting my point? Okay. Now see, there is a mistake in this slide. This quantity is not 3, this is 1. Okay. Or basically this can be written as, there is a slight mistake. It will be 1 upon 4 pi r1 square minus pi r2 square. Okay. Now question is asking for this area. Question is asking for this area, right? Now what we are going to see here, there are two quadrants. How many quadrants are there? Let me show you. There are two quadrants of a circle. One quadrant is this green part, and one quadrant is this blue part. And we know that the area of quadrant is what? Pi r square by 4. So if I'm asking for this area, then what I'm going to do, I'm going to subtract the area of larger quadrant minus area of smaller quadrant. So for required region, it will be area of required region is what? Area of larger quadrant minus area of smaller quadrant. Okay. So the area of larger quadrant is what? Pi capital pi r1. Because see, the larger circle radius is what? R1, and the smaller circle radius is what? R2. So the area of larger quadrant is what? Pi r1 square, pi r1 square by 4 minus pi r2 square by 4. Now you can take pi by 4 common, it will gives r1 square minus r2 square. Now you can use the property of a square minus b square, which is a plus b into a minus b. So it will be pi by 4 r1 plus r2 into r1 minus r2. Okay. Now this is first one. Now second one. Now question is asking for what? Question is asking for that area. Question is asking for this area. Now tell me, if the side of this square, see the quadrilateral ABCD is a square. In this question, it is given that the information is given that ABCD is a square of radius of side, not radius of side A, and the radius of circle and radius of circle is R. So what we are going to do for that area of shaded part, we are going to subtract the area of square from area of circle. So it will be what? Area of circle, area of required region is what? Area of circle minus area of square. ठीक है? Now tell me, what is the formula for area of circle? Pi r square minus area of that square is what? A square, because side square is the formula for area of square, so it becomes A square. So what we got? We got this one. Okay, so this is our required answer for the area of this shaded part. If you see, pi r square minus A square we already given. Got it? Okay, now there is a question. Okay, now there is a rectangular sheet R-click. R-click is basically is a material used to making the sheet. Okay, it is a material. Is 50 centimeter by 25 centimeter. Now from it 60 circular buttons, each of diameter 2.8 centimeter has been cut out, then the area of remaining sheet. Now let me give you a simple example. Okay, now I see a photo. Now you can take this rectangular part as a sheet. So what I do, I just make the buttons from this. I just cut the buttons. Okay, I can make it again. There is a rectangular sheet. What I do, I just remove the buttons which is the shape of circle like this. One button, second, third, fourth, ऐसे ना, like this. If I remove these buttons, then the area which is left in the sheet is this area. This one, 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 that one, right? That one, that one, that one. So we question is asking for that area. So what we have to do, we have to subtract the area of 60 circular buttons from the area of that rectangular sheet. We got the remaining part area, isn't it? Isn't it? Yes or no? Are you getting my point? So what I told you, area of remaining sheet is equals to area of rectangular sheet minus area of 60 buttons. Okay, now first of all we are going to find the area of that rectangular sheet. So the area of rectangular sheet, so it will be what? Side into length into breadth. Yes or no? L into B is the answer, isn't it? So it will be 50 into 25. How much you got? 50 into 25. What is 50 into 25? 25 into 5 is what? 125. 121 is, it will be 1250 centimeter square. Okay, now area of 60 circular buttons. Area of 60 circular buttons. So it will be 60 into area of one button. So radius is what? See, 2.8 is the diameter. So 1.4 centimeter is the radius. So 60 into pi r square. R is what? 1.4 ka square. So you can take 60 into 22 upon 7 into 1.4. 7 time cancel out, it will be 0 point times. So how much you got? You got 60 into 22 into 0.2 multiplied by 1.4. So if you multiply that, how much you got? You got 369.6 centimeter square. Now the answer is what? Answer is what? Question is asking for what? The area of remaining part. Question is asking for what? Area of that remaining part. So I can do here, okay? Area of remaining part. See, as I told you earlier, what is the area of remaining part? Area of that rectangular sheet minus area of 60 buttons, right? So the area of rectangular sheet is what? 1250 minus how much? 369.6. 369.6, right? So if you subtract these two quantities, how much you got? 880.4 centimeter square, isn't it? So what the answer? What answer you got? You got 880 centimeter square. If you see, we got the same answer, isn't it? First, we are going to find the area of that sheet, then 60 into area of one button, which is this. So we got the same answer. If you see, 31250 area for the rectangular sheet and 369.6 is the area for that 60 buttons, and we are going to subtract them, then we got our answer, isn't it? Are you getting my point? Okay. So next, there are some practice questions. Okay, in today's lecture, we are going to do two questions, first question and second question. You have to do third question for your homework. Okay. Okay. Now see, the inner diameter and the outer diameter of a circular path is given respectively. Now find the circular path area. Simple question. So first of all, area radius of inner radius, basically inner radius of circular path is what? 700 upon 2, which is 350 meter. Outer radius of circular path 728 upon 2, which is I think it will be 364, right, meter. Now question for area of that circular part is what? Pi capital R square minus small r square. So area of circular path is pi capital R square minus pi small r square. So you can take pi common, it will gives r plus r into r minus r. So if you solve further, pi is 22 by 7 into r, capital R is what? 350 plus 364. 350 plus 364, it will give, and 350 minus 364. Or not, we are not going to write down 350 minus 364. It will be 364 minus 350, isn't it? As I told you earlier, if you take 350 minus 364, it gives a negative answer. So it will be 364 minus 350, isn't it? Okay. So it will be 22 upon 7 into 714 into 14. So this will be cancelled out by 2 times. How much you got? 714 into 2 into 22. So if you solve this, you will get 31416 meter square. You will got this area. Let me check the answer. 31416 meter square. Yes, we got the correct answer. Okay. If you see, we got the correct answer. 31416 meter square is the our required answer. Okay, now next question is what? Chord AB at a distance of 7 centimeter from the center of a circle subtend an angle of 120 degree at the center. Then what is the area of major segment? Okay. Now in second question, it is given that there is a chord of a circle which is at a distance of 7 centimeter from the center. Means the distance from the center is given 7 centimeter and the angle made is 120. So this angle will be 60 degree. Okay, so the question is look like this. A circle is there, a chord is there. The center is 7 centimeter apart. This complete angle is 60. So this complete angle is 120. So this part is 60. Now, question is asking for major segment. So what is the formula? What we are going to do that major segment area? First of all, we are going to find the area of minor segment. Then we have to subtract that area from what? From what? Area of that circle. We are going to subtract that area from that circle. So for minor segment, area of minor segment, area of minor segment. See, for area of minor segment, what we have to do, we have to find out the area of that triangle. So for that, what we need radius and this height. So with the help of concept of cos theta and tan theta, you can find that, right? I just give you the hint for this question. You have to do this question by your own. Because this is very simple question. I just give the hint. So with the help of cos theta concept, you can find the value of this hypotenuse and this perpendicular with the help of tan theta concept, because there is a triangle. This angle is 60 degree, this is 7. So with the help of cos theta you can find this one, and with the help of tan theta you can find this one. So means you got the radius, you got the base and height of this triangle, isn't it? So means you got the area of triangle, you got the area of that sector, means you got the area of this segment. Now for the area of major segment, what you have to do, you have to subtract that area from the circle itself. Very simple question, you can do this, right? Okay, so this answer you will got. Okay, so you can try these two questions. This is your homework. So what we learn in today's class, we are going to take a quick review. We learn about what? Area of circular path and ring, area of segment, and area of combined figures and plane figures, combination of plane figure. So area of circular path and ring is what? Pi into capital R plus small r into capital R minus small r, isn't it? So this formula we do so many questions after this. Okay, now there is a formula for area of segment, but I told you we are not going to use the direct formula, we are going to do by method, and the method is this. Okay, then we do some questions. Now area of combined figure, we are going to prove this, what is the area of these two figures, and one question we are going to do. And after that there are some practice question, one question we already done, and these two questions are for your homework. I already teach what we have to do in this question, second question, right? Okay, so the lecture is completed for today. This is enough for today. So in next lecture, we are going to finish this chapter. Okay. So thank you so much. Stay safe and enjoy. Hope you see you in next lecture. Thank you so much. Bye.